Before moving on to the next high-level function, it's required to learn something new in between. The one high-level function that you know right now is dlmread. The next one is xlsread. But before we can do xlsread, we need to understand what cell arrays are. These variables are used by xlsread, but also to create dialog boxes. After seeing the definition of cell arrays, we'll see how to create, reference, augment, and slice them. Right now, if you recall the workspace, we've seen three types of variables. Strings, in MATLAB are called char, doubles, or logical results. But cell arrays will use a completely different new logo, which is the curly braces. Now, a data type that stores values of different types in indexed data containers are called cells. What this means is that a variable can hold multiple data types. This is something we haven't done yet. If we had an array, it was either all numbers or all single letters. But now we can officially store every data type in one single variable. The mental picture is a ship container. This is exactly the idea of a cell array. Every single container can contain anything, including another ship. You can see how this is very useful for database. Simply, it is an array of cells. Quick vocabulary before we continue. Parentheses, brackets, and braces. Cell arrays specifically will use braces. As far as creating the cell arrays, we can use them with the braces. The logic behind creating new rows and new columns is identical to what we know before. Commas will separate columns, and rows will be separated by semicolon. Like arrays, cell arrays needs to be rectangular, so we still can have a funky array with holes in the middle. Now you'll notice the difference when writing them on the command window. Not only do we need to use curly braces, but you also see a lot more brackets everywhere else. MATLAB sort of shows you that they are containers. We can actually visualize a cell array using cell plot. The variable in the workspace won't be as nice as looking as a numerical array. With numerical arrays, if they're small enough, we used to be able to see the actual values in the workspace. But now all you will see is the dimension of the cell array. However, cell plot will actually show you visually what every container contains. This is just a representation. Joe in the third cell, for example, is a string. The J is in the first box, the O in the second, and E is the third. But MATLAB compacts everything. Cell arrays can of course be two-dimensional. For example, here we have a 2x2 cell array, so 2 rows and 2 columns. However, notice inside each container is simply completely different. The first one contains a numerical array of 4 columns. The second row, second column contains one string with 5 letters. And the other two contain one value only, but one is a double while the other one is a char. So we have a complete mix all across the containers. Test your understanding. Can you tell if this cell array, you notice we have curly braces, is rectangular or not? It is. While individually the number of elements in each container is different, the overall containers are stacked on top of each other. The size is a 2-row by 1 column. So 1:4 is the top, 1, 2, 3, 4, and 2:3 is the bottom. How about referencing? Like with numerical arrays, rows and columns indices are used. But unlike numerical arrays, there are two ways to reference a cell array. You have to think about the container or the content. If we want the actual container, so maybe to move it, to copy it, to replace it, or even to delete it, then we need to use regular parentheses. But now, sometimes, we might need to access the content. And in this case, we will need to use the braces. Maybe we want to change or empty its content, or display and print, more likely. Let's see some example. Here I use regular parentheses to reference the first row, first column. Notice how MATLAB does not show me the content. Regular parentheses only access the container. So MATLAB tells me that in row 1, column 1, there's a 1×4 array of double. But that's it. MATLAB did not go inside the container to see the content. If I want to do that operation, I will use curly braces. And in that case, I am telling MATLAB, open the doors and look inside. So MATLAB actually shows me the content. This becomes very important when you want to use the value. Suppose you want to do a mathematical operation of adding 5 to all the elements of the array in cell 1,1. If you use cell 1,1 with simple parentheses, MATLAB will scream. Again, you didn't tell MATLAB to open the doors and look inside. So MATLAB wants to add 5 to a container. That doesn't mean anything to MATLAB. So this version doesn't work, but the other one works. To add 5 to the content, so to the vector of values inside cell 1,1, use curly braces. In that case, MATLAB opens the door, looks at your vector of 4 elements, and adds 5 individually. This becomes also important when you want to print. If you again want to print a container, it doesn't make sense to MATLAB. Container row 2, column 1 will scream. Function is not defined for cell inputs. It's like trying to tell MATLAB, please print this container, but don't look inside. That doesn't make sense. Same thing for strings. It doesn't matter the data type inside, MATLAB cannot automatically open the doors. If you want to print the content, make sure you reference the content of the cell array. So in this case, curly braces. To use the actual parentheses is called cell indexing. You're using the index of the cell, but not the content. The content indexing uses curly braces. Besides that, a lot of operations are very similar to using normal arrays. For example, if we want to augment, suppose we want to add the string def to this already existing cell array. Visually, we want to glue on at the end a def. If we use the curly braces method, curly braces are used to create cell arrays. So we won't end up with the result wanted. Curly braces create a new cell array. In the first container, we'll glue all the previous containers, and in the new one, we'll add def. So visually, you see what we have on the right. We have 2 containers, but inside the first one, there's 4 containers, and on the second container, there's just a string. That's not what we wanted to do. So, just like regular arrays, square brackets are used to augment. Adding a row and adding columns are identical to normal arrays. Semicolons will tell MATLAB go to the next row. And just like normal arrays, make sure you stay rectangular at all times. Slicing is a little bit different. Remember that the content of one cell is not connected to the content of another. There are doors in between. Slicing the content is actually not practical. Slicing the cells remains the same. For example, imagine you have a cell array called data. It has the name in the first column, the ages in the second, and the third one is grades. If you just want to slice the ages, so the middle column, column number 2, there is again 2 ways to look at it. Slicing the cells can be done. Data, open parentheses, 2 to the n, because you don't want the title, and column 2. In this case, MATLAB slices perfectly, but keeps it a cell array. Notice how you see the brackets on each single number. Visually, that shows you it's still a container. Slicing the content will produce surprising data. Although you did tell MATLAB go inside each cell, 2 to the n, comma 2, MATLAB only returns the last one. What happened? By not collecting the return value, you can actually see that MATLAB did go inside each cell, but individually. It cannot grab the content all at once since it has to open and close doors every single time. So MATLAB did loop through the slice, but it only kept the last one. Slicing the content is not usually what you want to do. Slice the actual containers. More common operations, and you'll notice they're very identical to normal arrays. If you want to delete the cell, actually really delete, it's the same exact syntax as with normal arrays. And identically, this cannot be undone. You cannot hit the Ctrl-Z key or do any kind of coding that would bring it back. But now you do have the option of emptying a content, meaning leaving the cell, leaving the container there, but deleting the content. Notice the difference. You use curly braces instead. You can of course replace a content by another one. There are 2 ways. Either you access the content immediately using the curly braces, or you tell you want to replace the whole container by a container, so notice the little curly braces again, with the new content. You can do the same with numbers. Either you replace the container's content, that's option 1, or you replace the container itself with a completely different container. Transpose of course still works. These are, after all, still arrays. Now, using all the functions that you used on previous arrays can be a little bit tricky now. Again, here is a variable, 3 by 3, but it's not what it used to look like. This is a cell array, so 9 containers total, and each one has 1 numerical data. If you wanted to sum column number 1, what we used to do in the past with the sum, x is the name of the variable, which rows, all of them, comma, which column, 1. Again, remember that the containers are closed. MATLAB does not go inside automatically, so sum is not defined for cells. You may think that putting curly braces might solve the issue. But again, you cannot slice individually the content, so the sum still crashes. Instead, we might have to convert. This is actually very simple, 1 line of code, cell to mat. This will automatically convert a cell of numbers to a numerical array. So you can now use the sum, the prod, and any other kind of functions that you have. In the workspace, you'll notice 2 very different logos. X is a cell array, and X1 is a numerical array this time. So again, sum of x1, all rows column 1, will absolutely work. Why would we use cell arrays? Well, you can see that any database that we currently use in our cell phone has name, numbers, different data types. So that's definitely something powerful. Store different arrays of different sizes. Nothing restricted us of the content of each cell. We can have a different size in any different container. We can even store strings of different length everywhere. The key idea here is cell arrays are containerships, arrays of cells that allow storage of different data types in one variable. We now have to be careful about the 3 different types of braces we can use. Curly braces for creating and referencing the content, augmenting, so making it bigger by regular brackets just like old times, and referencing the cells themselves, so the actual container, using regular parentheses. Slicing is the only thing that can be challenging. Do not try to slice the content. That never really works. Instead, slice the actual containers themselves, and then possibly use cell to mat to convert to a regular matrix.